In the last lesson, we learned what a rational number is, or what rational numbers are. And just a reminder, a rational number is any number that can be expressed as a ratio of two integers. So if we write a over b, where a and b are both integers, it can be written as a over b as long as b does not equal 0. So what does that mean? Well, a is an integer, and integers, just a reminder, are any positive or negative numbers, and 0, where b can't be 0. So let's take a look at this. Graph each of these numbers on a number line. Okay, we have 5 over 2. We have negative 1.2, and we also have 7 over 4. Okay, now we want to graph on a number line, so let's draw a number line. And here's 0. There's 0. Let's say we have negative 1 and negative 2. Let's make it a little bit longer. And that'll be, let's go a little farther, negative 3. And then on this side, we have a positive 1 and a positive 2. And that'll be about 2.5. So this first one, 5 halves. Well, 5 halves on a number line, if you have 0, then there would be 1/2, 2 halves, 3 halves, 4 halves, and 5 halves. So it would be right about there, 5 halves. Okay, and we did that because 1 is actually 2 halves, so we counted 1/2, so that would be 1/2. Then 1 is actually 2 halves, so you can write it, or 2 halves. And then 3 halves, and then 2, it would also be 4 halves, and then 5 halves. Okay, that's the first one. Now, negative 1.2. Well, that could be written as negative 1 and 2/10. So negative 1 and then 2/10. So if you divide it into tenths, you'd have negative 1 and 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then negative 2. So negative 1.2 would be negative 1 and 2/10, which is right there, negative 1.2, negative 1 and 2/10. And then we have 7/4. 7/4. So if you cut 1 into 4, if we mark fourths over here, that's 1/4. And then 1/2 is the same thing as 2/4. So 1/2 or 2/4. And then 3/4. And then 1 would also be 4/4, right? 4 divided by 4 is 1. And then we have 5/4. 5/4. 1.5 or 3 halves would be 6/4. And then we have 7/4. So 7/4 would be right there. And if you count them, you have 0, 1, 2, 3, 4, 5, 6, 7/4. And then 2 would have been 8/4, right? Because 8 divided by 4 is 2. So that would be 8/4. So we labeled our points here. We have 5 halves, we have 7/4, and we have negative 1.2. So that's putting them on a number line. And if you're able to do that, then you should be able to compare these rational numbers. So in this next part, we want to use either less than or greater than to write a true sentence. So let's compare these. So 1.38, so 1 and 38/100ths compared to 1 and 83/100ths. Well, if you were to picture these on a number line, you'd have 0, 1, and 2, and they both fall between 1 and 2. But one's 1.38, 1 and 38 hundredths, and one's 1.83, 1 and 83 hundredths. The 1.13 is probably about there, 1.38. And then the 1.83 would be closer to the 2. So 1.83. And you'll see that 1.38 is closer to 0, so it's actually less than 1.83. So we'll put less than. 1.38 is less than 1.83. Okay, this next one, negative 3.45, negative 3.45, and 1.32. So negative 3.45 on a number line, let's say 1, 2, and that's negative 3. Negative 3.45 would be over here somewhere, negative 3.45. And then we have 1.32. So there's 1 and 2. And it's going to be somewhere between 1 and 2, but less than 1.5, so probably about there, 1.32. Now, negative 3.45 is farther in the smaller direction than the 1.32. So we can say that negative 3.45 is less than 1.32. Is less than. Okay, this next one, we have negative 4.23 and negative 5.2. So let's draw another number line. And we have 0, negative 1, 2, 3, 4, 5, and 6. So negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and then there's 0, and we have 1 and 2 over here. Okay, negative 4.23. So you count 1, 2, 3, 4.23 will be about there. Negative 4.23. And then negative 5.2. So negative 5.2 would be about there. So we can say that negative 5.2 is actually less than negative 4.23. Or you can say that negative 4.23 is greater than, because it's farther to the right, and that's going to be greater than. So negative 4.23 is greater than negative 5.2. So that's how you compare. That's how you can compare the different rational numbers. And notice all of these are in decimals, but rational numbers are fractions. So we could compare two fractions. We could say 3/4 and compare that to 5/8. 5/8. And when we compare fractions like this, we need the same denominators in order to do that. So you need to find the least common multiple of the denominators, or what number could both denominators go into. So a 4 actually goes into an 8. So we can change 3/4 to something over 8. 3/4 equals something over 8. And how we do that is, well, how do you get from a 4 to an 8? Well, you have to multiply it by 2. So 4 times 2 is going to give us an 8. So if you do that to the denominator, you also have to do it to the numerator. So 3 times 2, which would give you 6. So 3/4 is actually the same thing as 6/8. And now we can compare 6/8 compared to 5/8. Well, 6/8 is larger. It's larger. We have more 8s than the 5/8. So we can say 6/8 is greater than 5/8. And if you wanted to see that on a number line, you could do 0 and 1 and divide this into 8s. So that would be 4ths, and then divide each of the 4ths. So there should be 8, right? 1/8, 2/8, 3/8, 4/8. 5/8 would be there. 5/8. And then 6/8 would be right there. 6/8. And then we have 7/8, and 1 is the same thing as 8/8. So 5/8 is actually less than 6/8, or you can say 6/8 is greater than 5/8. So that's how you compare rational numbers. And I hope you have a little bit of a better understanding of rational numbers. You may need a little bit of practice with this just to get it solidified, but if you ever doubt yourself, it's always a good idea to draw a number line in order to compare and just plot those rational numbers on the number line, and then you'll know which one's greater than and which one's less than.